Hello guys, welcome back to Swat Tuts. Here I am back with another interesting tutorial. Today we are going to look at specular anisotropy in Arnold, and with that we are going to create this interesting render output. So what is interesting about this output is that we are going to create a scratch shader which is circular in shape, or what we usually call a swirly scratch shader. So you can see here that all the scratch marks are circular in shape and it is around this specular. So you now be wondering why this is special, or why not this be made with the textures. So the difference between making this in a texture map and creating this procedurally is that if I change, let's say I'm changing the directional light direction to any other location, if you see, you can see here that the scratches are again around that particular specular spot. So if you are, let's say, adding these circular shaped scratches in a texture, it will be placed in a single space, like in a fixed space in the UV, and it will be visible in a fixed space on the object. So here it is wherever we move the light specular, or when we move or rotate the light, wherever the specular highlight of that light moves, the scratch shader will create these swirly scratches around that specular spot. So this is kind of a procedural thing, and you can see this in a lot of surfaces. This is more commonly visible in smooth table surfaces, or you can see this in lifts, or you'll definitely be seeing this in a car windshields or car metallic body parts. So how is this effect is happening, and what is the background process behind this workflow? That is what we are going to look at today, and we are going to use an OSL shader for this particular effect, and I'll explain a bit more about what OSL shader is in a bit. So first of all, what I'm going to explain here is that how this effect is creating inside a shader. So we'll be creating this effect using an OSL shader and using specular anisotropy in the AA standard surface shader. So here we'll be looking at what specular anisotropy is, what an OSL shader is, and how with specular anisotropic attributes we can create this procedural swirly scratches which moves with the animation in specular highlight. So as usual, I'll be explaining the basics about specular anisotropy. Then I'll be going into detailed workflows of how you can create this scratch shader. So I know that not everybody is interested in going through all the basics and these theoretical talks. So for that, I have put the timestamps on the video so that you can just directly skip into the OSL shader part if you need to, so that you don't get bored with the theory and basics behind the specular anisotropy. These videos are more intended for the beginners so that they have a better understanding about what they are doing and how this thing works. So without further delay, let's talk about specular anisotropy. So the word anisotropy means irregular, or in this case, it is the reflection which is stretched along a particular direction. So let me just first disable this effect for now so that we can a bit more on the basics of specular anisotropy here. So let me just remove this from all the parts. So here I have created a symbol shader for this tutorial, a metallic shader which has a weight of 0.85 and metalness completely 1. I'll just add a little bit of roughness here, let's say 0.1 or let's say 0.05. So you can see, since I am using a directional light for this to get this specular hit here, you can see that, as you know, directional light doesn't have any specific size. We adjust the size with this angle value. If I put this into 0 and update the scene, you can see if you increase this, you can see the size of the specular spot increases. So even though you can see that even if I increase the specular spot, it creates this circular shape, which means that the light is hitting on a particular spot, and because of the roughness of this particular object, you can see that if I increase the roughness, the spot gets bigger. But even though the spot gets bigger, it is uniformly spreading across all directions, which means it is from a point where the light hits that surface, it is spreading equally towards all the directions, and that is why it creates this perfect circular shape. So if I increase the size again here, let's say 50, you can see it's a perfect circle. And in anisotropic specular, the specular will be spreading specifically in a single direction more, so that it will create this kind of elongated specular. If I would show you here, if I come to specular and if I increase this specular anisotropy, let me just update it and see. Let me get this back to, let's say, 3, and let me increase the rotation as well. Okay, because this roughness was 0, it was not affecting. So let me put it back to 0 and then let me increase it. So you can see by default, if I put it to a value which is more than 0, it stretches the reflection or specular highlight in a particular direction. And with this rotation attribute, I can rotate this in 360 degree along that particular axis. So these are the only 2 attributes which is given in a standard surface for the anisotropic rotation. And this is not a physically existing attribute. This is more of like a attribute which is given to mimic this effect. So in real world, anisotropic specular reflections happens because of a few reasons. One would be the light angle, the angle in which the light hits a surface, and then again, if there are some surface normal variation or deformations on the surface that can create these kind of specular stretched reflections. Then most importantly, if you have observed brushed metals, mostly this will be a common effect which is visible on the brushed metals. Also, some of the clothes, kind of like silk, will create these stretched reflections, and there are a lot of other examples as well. So on all of these materials, the main common element will be that these will have, let's take the example of brushed metals, where it will have this macro horizontal or vertical parallel lines. Each of them gets specular spots, and together it will create a line of specular which feels like a stretched specular reflection. So if I want to show you an example here in a Maya scene, let me just hide this sphere and create a cylinder here. So I'm going to rotate it on 90 degree and scale it down a bit, and then let me just create an elongated cylinder, and let's try rendering this. And I'm going to assign the same shader for this one as well. Okay, let me see if we can get a specular hit on this. So yeah, we got a specular hit in here. Let me just add a subdivision so that we don't get this kind of effect. Okay, here you can see it's already have this stretch because we have maybe put some anisotropy. So let's just put the anisotropy back to 0, and because this has this elongated line, we are getting this effect. If it was a flat surface, we would have got a circular shape here. And now let me just duplicate this and duplicate this like a few times. And if I see the reflection in a zoomed out angle, you can see it totally creates this stretch or a single reflection which is stretched vertically along this group of cylinders. So this is how in brushed metals the reflection will be in a macro level. If you zoom into any brushed metals, you can see we will have these kind of smaller lines of bumps or bump detail which is stretched along, like goes along those lines, and each of them will catch these specular separately, and together, if you are looking from a long distance, it will look like the reflection is getting stretched along the way. So let me just again try to duplicate this, and for the time being I'm going to adjust the roughness a bit so that we get more lower reflection. So if, let's say, I am placing another cylinder with the same shader, let's rotate this, move it along this side, and just scale it equally like how it is. So you can see on a single surface which is smoother how the reflection is behaving. It stretches along the cylindrical shape, and when a lot of them together are viewed from a distance, it feels like the reflection is like rotated 90 degree and stretched along the perpendicular direction. So this is how basically in all objects specular anisotropy happens. It is because of the macro surface details which is catching these specular spots, and we are watching it together and we feel like the reflection is being stretched. So in here we are using the same technique but with procedural OSL shader. So this was created by this guy. I don't know exactly what his name is. I got this from the Arnold render blog. This tutorial or these renders were created by Lee Griggs, and he mentions here that he got this from a guy called Freemind, and this is a post from Twitter. So this is his GitHub page, and I'll put the links in the description. You can check that out, and you can easily, without even watching this tutorial, you can get this. You can download this directly from this site, and here you have this node structure he has given, and he has mentioned here which attributes are connected to where in the shader, and you can easily create this effect. So since there is no video tutorial regarding this in the internet, I thought I would make a simple tutorial with this, explaining some of the details like what I know about this, and that is why I've decided to move forward with this tutorial. So since I hope you get an idea about these specular anisotropy and how that happens. So to create this effect simply, we have this two attributes inside Maya, which is anisotropy, which creates that stretch along one direction, and this rotation. So let's see another example where I have in this sphere added a bump map. So let me show you the bump map here. It's a fractal map which has this stretch. So I have added repetition of 100 along one direction so that the map is stretched along a single direction, and then I have adjusted it with an AI range so that I can adjust the bump values directly from here, because by default these values were really high, and I have connected this to a bump map here. So by default, without any of this bump details, you can see, let me just bring my directional light to the camera view so that I can adjust this from the camera itself. So I'll rotate this and bring it more to the front side, and I'll just add a bit more roughness to it so that you can clearly see the effect. So here we don't have any bump maps added, so I'm going to add the bump map bit by bit. And as you can see, as the bump map is increased from 0, it is a perfect circular shape, and as I am introducing these stretched bump details onto the surface, you can see how much it stretches these specular highlight into a particular direction which is perpendicular to the direction of the lines. And if I here come back into the texture and again rotate the frame, here I have put the rotation value of the frame to 90. Now let's put it back to 0, and now the stretches are in horizontal and the specular anisotropy has stretched vertically. You can create this brushed metal effect with bump details as well. If you want to create the specular anisotropy in a realistic way, this would be the method, because the breakups should be actually there to break or stretch the specular into a particular direction. And also you can introduce the rotation and anisotropic values as well if you need, so that you can enhance this effect more. And the disadvantage of creating these anisotropic reflections through bumps and displacement is that it is going to cost the render more, because we are adding or displacing the mesh more, and because this is like a really macro level details, you will need a lot of camera samples to sample these smaller areas, which will create a lot of render time. So an easier method would be to create it with an anisotropy and use the same bump detail in the roughness map. So with the OSL shader, that is what we are going to do. We are going to create the same effect or these swirly scratches without using any bump or displacement, only by using specular roughness, specular anisotropy, and specular rotation. So let me just bring back the OSL shader which I had. So if you want to see how we can create this OSL shader, let me just create it from scratch. So from the website, you can go to the Scratch OSL shader and you can like copy all this script, come back to Maya. So let me just give a quick brief about what OSL shader is. OSL means Open Shading Language, which is a shader which will be common for all the render engines, which means that if you are using this in, let's say, Arnold render, you can also use this in RenderMan, depending upon how the programmer has coded this shader to be. So it can behave a bit different according to which render engine you are using, or how the render engine perceives those codes inside the render engine. But this is like a common language for all the render engines, where you can create nodes, fractal nodes or noise nodes, or symbol shaders or color correct nodes, those kind of things, simply by coding inside this Open Shading Language. And you can add or use this node inside any render engine or software. It is common for every software. So like I said, depending upon the codes and the versions, some may not work properly in some render engines or softwares, but apart from that, everything is going to work more or less similar in all the render engines. Even in here, he has clearly mentioned that there are two different settings which he has done, one for Claris and different for Maya. So like that, there will be some slight differences between software to software or from one render engine to another. Other than that, you can like mostly use all of them pretty easily. So I have created here an AI OSL shader node, and you can just click in the compile OSL code area and just paste it inside the code area, and then you go down and click on compile OSL code. So once it is compiled, it will show you the status here, which is compile success. If it is showing an error or compile failure, that means it didn't work on that software, which means if you are a programmer and you know how to fix this, you can fix this, or else there is no other options. For me, I have no knowledge, so if it is working, I'll use it, or if it is not, I have to find another way. So we have some of the options here. So let me just connect the out value to an AI range first, just like how he has shown in here. So the out value goes into an AI range here. So out value to input, and then like it has mentioned, the out color red will go into the specular roughness. So I'm going to use the out color red channel in the specular roughness, and I'm going to put the bump value back to 0. So here, if you look at it, by default we are getting something in here. So we have the first attribute, density, which is how much denser the scratches should be, then roughness min and roughness max. Then we have a roughness default. So roughness min and max is minimum roughness and maximum roughness values of the scratches, and the default value is, from what I observed, is for the area which is not affected by the scratches. So I'll put a value 0.05, and I'll maybe increase this. You can see here, if I'm increasing the roughness max, the area affecting is the scratches. So before going into that, let me just isolate the scratches and we can see what the scratches are. So if I increase the density, let's say 0.5, you can see the density of the scratches increases. And the red channel is what we have connected to the specular roughness. You can see the red channel in here. If I go particularly into the R channel, it is the area which is under the scratches. And the green channel are the scratch values. And if you look at it closely, there are different luminance values for each of these lines. So if I read the value here of the green, it is around 0.052, and this one is 0.1, and this one is around 0.282. This is 0.345. So each of this has a different value in the green channel, and then the blue channel also has this different values in it. So if we, let's say, go back here, in here the red channel is what is going to be in the specular roughness, and the green channel is what goes into the specular rotation, and the blue channel is what goes into the anisotropy, just like what we have seen here. So the green channel goes into the rotation with an AA negate, which is specifically he has mentioned for Maya, because he has to like inverse the values of what we are getting by default in the OSL shader, and then we have to add an offset, and we have also an isotropic min and max, then another default value which is already like what we had seen for the roughness on the surface below. Width is the width of these scratch lines. So if the default is 0.001, we can go into 0.0001 as well, which will create really smaller values, which is barely visible here. You can see it here. So let me just put it 0.0005 so that it's there, but it's not that like clearly visible. So these are all the default values. Let me just connect to the other attributes as well, and we can see how it affects those. So I'll create an AA negate value, and I'll put the green input into just the R channel, and I'll take the same out color R into the specular rotation, but here it's not visible, so I am going into the top side and selecting other, and here you can see the specular rotation, and then again selecting the blue channel and again going into the top circle connection here and connecting it to the specular anisotropy. So nothing much has changed here. The shaping is still random scratches here and there. So we need it to have a circular shape around this specular spot. So for that, the last thing we need to do is, here we have an offset. We have to put this into a value of 0.25. And you can see as soon as we have put a value of 0.25 there, some of the scratches are going around these specular spots. So this is still not exactly like a specular, it's more like a square shape. And if I increase the anisotropy, you can see more and more scratches will follow those paths. So here is how you can easily create this specular anisotropic or swirly scratches inside Maya with this OSL shader. So if I move this, you can see the scratches are moving with the specular, as well as it's creating those circular shapes around that specular spot. So this can be added onto any surface, mostly plastic surfaces or glasses, to create more realism to your elements. And I have never tried this, but I am hoping that it can be used along with another layered roughness as well. So let me try this as well. I am going to create an AI layer RGBA here, and I'm going to create a fractal texture, and let me just add an AI triplanar so that I don't see any seams. So I'm going to add this into the specular roughness. So let me just adjust the fractal a bit here. So Then I'm going to add an AI range to like make it really subtle. So you can see we have the roughness from the fractal. We are getting this nice breakups, and as well as we are getting this swirly scratches. So I'm going to add the scratches as well as a layer on top. I'm going to use the input 2 here, and I'm going to add the R channel onto RGB channels of the input 2, and I'm going to add this over the current fractal roughness. So I can like adjust the mix to adjust it over the current like fractal specular roughness, and we are getting this amazing specular breakup along with this swirly scratches. If you are still like didn't get this properly, like how this specular circular shapes happens, like I said, each of these lines have this separate value from 0 to 1, and as our anisotropy and rotations works from 0 to 1 values, if a line which has, let's say, 0.2, it will have a separate rotation, and another value which is 0.4 will have a separate rotation, and with anisotropy it will have this stretched reflections. And what I still don't completely understand is that how it recognizes where the specular spot is hitting and how to like create this circular around that specular spot. So I'm a bit blind on that part there, and I don't have the explanation right now. And I think for a practical use, you don't need to know how that happens. It just works good, and I have explained all the attributes of the OSL shader. So if you want to increase the density a bit more, you want to see more scratches around, you can increase the density. Roughness, you can create a minimum roughness and another maximum roughness so that it's more clearly visible there. So all of this you can do pretty much with the attributes as well. I don't think we need to understand any more background process for this to create this kind of wonderful effects with this shader. So I hope this makes sense and you can create wonderful effects with this. So I would like to see more of you doing this and creating these kind of wonderful effects, not just on sphere. Like I'm showing this to just to demonstrate you how you can create this effect inside Arnold render and Maya. You can try it in Houdini or any other render engine as well with the same render engine, because the settings of this kind of like the changes in the offset is only specifically made for the Maya render. So I think maybe there is another settings which you have to tweak in if you are using any other render engine. So I'm not sure about that. You can like try experimenting with the settings a bit. So this is all I wanted to talk about in this small tutorial, and I hope this was useful and you can use this to create even more photorealistic shaders and renders in your personal works. And if you find this tutorial to be really useful, please support me to create more contents like this. And if you are watching this for the first time and you think this was worth your time, please do check out my other tutorials as well. And if you think that my channel is worth watching, please consider subscribing and leave something in the comments, and do like and share. Also share it with your friends who are also interested in lighting and look dev, and I'll see you soon with another exciting tutorial. Till then, this is Swat signing off. Bye.